Okay, now how can we use Excel to help us solve this question faster? So the equation just now we have just shown was this equals to 1 minus bracket 0.5 to the power of n plus n times 0.5 to the power of n. So now what you can do is, okay, you list down, but we have no idea what exactly will be n, but we list it down in this Excel. So 1, 2, 3, 4, 5. Just check how many times must we toss the coin to get the probability that we want. So the probability p more than 1. P more than 1 is this is the one. So it is equal to this. So p more than 1. Then you type down your formula here. Okay, this formula is this. So 1 minus 0.5 to the power of n. Okay, it starts from 1. But because this n is a variable, so I cannot type 1. I have to put in d1, the position of this number. d1 plus d1 times 0.5 to the power of d1 again. So this is what I type. Then once I enter, I get this value, which is 0. Then I just drag, okay, as many as I want. Because why is it no value? Because there's no value here. If I type 12, then it will give me another value. Okay, 13, it will give me another value. So on and so forth. 14, it will give me another value. Okay, but what is the question? The question says more than 95%. So this is 93.75%. This is 96%. So how many times do you think you need to toss to get a probability more than 95%? 8 times. Okay, so the answer for n is 8 in this case. You can see from the table. And now for question 17. Question 17 basically is they have provided you with n and p. N being the number of times you perform the experiment. P is the probability of the event, of the desirable outcome. And this is the formula for binomial distribution. Okay, so I just put in all the data into my Excel. So I list down this table for x. X is the variable. Okay, n is a constant because we already know how many times that you will do this. So in this case, it's 10. And the probability is also constant, is 0.23. Okay, x is a variable. So you list down. In this case, you will do 10 times, right? So which means it will start from 0 to 10. 0 to 10, because n is 10. Okay? But each value will have a corresponding probability. So how do you calculate the probability? The formula. Now the problem is, how do you compute this in your CAS or Excel? So the command in Excel for NCR is called combin. Combin. So you type equal bracket combin. Combin is the command. From 10, you're choosing how many. Okay, for this case, the how many is 0, but I can't put 0 because this is a variable. If I put 0, then I have to do it for every one of them. This is not what I want. So I put C7, the position, instead. Okay, multiply P. P is 0.3 to the power of X. But we don't put 0 here, we put the position, C7, times 1 minus 0.3 to the power of 10, n minus x, 10 minus C7. Then you press enter, you get a value. This is the value. Then what you need to do is just you drag. Initially all these are empty, right? So once you just need to do one time, and then just drag, you get all your data. Then once you get all your data, what you need to do is you select them all, then you go to insert, then you go to scatter, and you can choose this one if you want. I think a line looks better. Then your graph will be plotted. So this looks like the normal distribution. So it is telling you that the probability would be the highest when x is around 3. Okay. Likewise for question 18, it's just the same. It's just that your n and your p value has changed, but the method remain the same. So please use your CAS or your computer Excel to perform this.